Okay, we'll do some important types today
Mm. Mm.
of these probability questions. So first type is related to dice coin problems. Okay.
Mm.
Okay, let's get started with this.
Mm. One second.
Mm.
Mm. 6 cube has faces numbered 1 to 6. Mm. 5 by 36.
Okay, so many problems in dice coin or other varieties can be solved using enumeration.
Mm.
And here the sum is 8. So there are two rolls. And the scenarios are sum is going to be 8, right? So 2, 6, 3, 5, 5, 3, 4, 4, 6, 2, 5. And totally there are 6 cross 6, 36 combinations, right?
Mm.
So probability is 5 by 36. Favorable divided by total. Yeah. So enumeration is the key in many problems. So we will keep doing enumeration wherever required. Okay, next one.
2 number cubes with 6. Fifteen by 36.
15 by 36. Yes, 15 scenarios in all.
Mm.
Okay, good. All right, next one.
I mean, 1 by 36, no?
Yeah, 1 by 36. So 3 dice.
Mm.
And it can be either this, all the way till this.
Mm.
So 6 outcomes, favorable outcomes, and total are 6 into 6 into 6. Yeah, so 6, 1 by 36. Okay, good. Next.
1/3.
1/3. Okay, good. Okay, I will not explain this. It's easy. All right, this is important.
Mhm.
Let's see. Fair coin is tossed 7 times. What is the probability?
Probability that the number of heads is 1, 2, 3, 4, 5, 6. मतलब probability number of heads showing. अच्छा, मतलब probability number of heads is showing 1, 2, 3, 4, 5 or 6. अच्छा. So that means not 7. 1, no? 1/7. I don't know.
No, 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 no. Take a step back. First of all, okay, so always in these problems, you need to find what is the uh,
Number of
sample
outcomes.
space. So
हाँ,
first of all, what is the experiment about? Number of heads. So
हाँ.
that's your experiment. What is the sample space of this? Can I say it is starting from 0 all the way till 7? Either 0 heads or 7 heads maximum, right?
Hmm.
0, 1, 2, 3, 4 all the way till 7, correct?
Hmm.
And what is given are all the ones in the middle, which are quite a few. So hence such kind of problems can be solved using 1 minus complement. Sorry,
Hmm.
complement method, which is nothing but 1 minus given sample space.
But why would it start from 0?
0 heads is also possible, no?
अच्छा.
Just like 7 heads means what? 0 tails.
Hmm.
So 0 heads is also possible. So this is the sample space, but we can write this as 1 minus the complement method is 1 minus the remaining in the sample space, which is 0, 7. Can I write it this way?
Mm-hmm.
Now, probability of getting 0 heads is what? Means all are tails only. No, there's only one way in which all are tails.
1 by
Just
8 then, no?
yeah, so these are 7 coin tosses, all are tails. So that is only one way of getting it. Okay, one way. And what about 7? Only one way of getting 7 heads.
अच्छा,
All
7 or oh.
all heads have to be 7, right?
हाँ.
One way. But we are asked about probability. Now, every coin toss, okay?
हाँ.
Every coin toss will have two possibilities, either tail or head. And same as the case everywhere. So the sample space, which is total, I mean, the total count of the sample space here is 2 raised to 7. Yes or no?
हाँ.
Each coin toss in two possibilities, head or tail. And
Okay.
hence the total combinations become 2 raised to 7. Yeah.
Hmm.
So here we have 1 plus 1, but it's divided by 2 to the power 7. So this becomes 2 by 2 by 7, but it's 1 minus. So 1 minus 1 over 2 by 6. So the answer is 63 by 64.
No, wait, 1 second, 1 second, 1 second. You took 0 and 7, right? So this is the 0 to 7 is the number of heads that are showing up.
0
है
and 7 in the complement method, I took 1 minus the remaining number in the sample space, which is 0 heads or 7 heads. And there's only one way in which you can get 0 heads, only one way in which you can get 7 heads.
अच्छा, okay, okay, okay. हाँ.
Now, this is the concept which is important.
How do you know when to apply this?
Uh, okay, so so first of all, you need to understand what is the experiment. Experiment is on number of heads. Once we realize that, we need to find sample space,
Mm.
which means sample space for what? Number of heads appearing. Then we see, okay, we have what is required are 6 outcomes, but sample space has 8 outcomes. So it's better to use complement method, less working. Yeah. Then
Okay.
I know, okay, if I have 0 heads, then that's only one way of getting 0 heads, which is all tails. Similarly, if I have 7 heads, there's only one way of getting 7 heads, which means all 7 tosses have to be heads. But it's a probability. So I have to divide that by total, right? Now, what is total? Total is for what are the total number of outcomes possible. So for each coin toss, there are 2 outcomes possible. So 2 into 2 into 2 is 2 raised to 7 because there are 7 coin tosses. So that's your denominator. So denominator in coin toss problems is always 2 to the power something, generally.
Okay.
Okay.
Uh, but okay, I thought sample space and number of combinations are different. No? Sample space and number of outcomes. Hmm. Okay, I don't know. I find this a little confusing. Like now, fine after you explain it, but then when do you apply it becomes a little confusing. At
Okay. I'll give you one more problem.
uh,
Yeah.
uh,
Now I'm going to ask you 7 coin tosses were made. What is the probability of getting 2 heads exactly? So how will you solve this problem?
2 by 2 raised to 7. No?
So one is favorable outcomes, numerator, and denominator is total, right?
Uh,
Total is, now it is what is total? 2 into 2 into 2, 2 to the power
that is
7.
2 raised to 7. Probability of 2 heads exactly. So
Ah,
there'll only be one such case, no, where there are 2 heads. Only
no,
2 heads. There could be
no.
more than 2 or less than 2.
So there are
Achha,
seven
you
coin
mean for
tosses.
okay, there are two could be in any of the 7 spaces.
Yes. So HH or HH, or it can so many combinations, right? It's very
Hmm.
difficult to understand now. You can't enumerate here. No, can't enumerate this. Which means all that they're saying is find or fix 2 heads out of these 7 places. Hence 7C2
Okay.
are the number of combinations possible of having 2 heads anywhere in a series of 7 coin tosses. 7C2 ways, which means any 2 places you take and fix them. And how many ways to do that? 7C2 ways.
But
Select
one
2 heads out of 7. Out of
So
7 tosses, select 2 heads.
there are 7 blanks, right? So if I say any one of the blanks has edge, then the other edge, that would be 7 spaces. The other edge would have 6 spaces, no? So 7 into 6. Why does it get divided by 2?
Because it's the same, no?
Oh, okay, yeah. But एक second. If I take 7 spaces, so the first edge took the first spot. Okay. And then there are 6 spaces. So the second edge took the second spot. So you're saying that उसको उल्टा भी करूंगी तो it's the same case. That's why.
हाँ, correct. क्योंकि exactly my point. So HTH, even if I were to flip it, is the same thing, no?
Mm.
But if these were a different item, then it was permutations proper.
Mm.
Here it is not proper because here HTH is same as HTH, even if I flip this and this.
Mm.
That's why. So whenever I have to select 2 heads out of 7, the selection will be used
Mm.
and not permutation here. 7C2 ways in which we can select 2 heads.
Mhm.
Or how many ways can you arrange 2 heads? Is 7C2 ways.
Okay. See now again, this. The way you
Another
saw
way,
this is different. No,
okay,
every
another
sum is
way,
different.
okay, okay, another way of doing this is, okay, this might be easier for you to understand. Now, suppose there are two heads, okay, and they can come anywhere. Suppose they are in this format, right?
Mm,
Now,
mm.
how many heads are there? Two heads. And how many tails are there? Five
Five.
tails. But can I say that these two heads are the same only? And these
Yeah.
five tails are the same. So there's repetition. Total, there are seven places, but then two items are repeating, and five items which are tails are repeating.
Mm,
So you have to divide total divided by 2 factorial, 5 factorial, because these five are the same only. And there
mhm.
are 5 factorial ways in which they are repeating.
Yeah. I,
And
I
hence, this
understand.
is 7C2.
I understand. It's just that I get confused when to apply what. That's where I struggle. So both
Okay.
sums are like it makes sense, right? The solution, but when to apply what becomes a little challenging. That's where I struggle a bit.
Hmm. So that will come with practice, and that will come with a bit of more understanding.
Okay.
So right now, as we stand here, you know that, okay, we need favorable outcomes, we need total. In coin tosses, there is a way in which we can enumerate, but enumeration becomes difficult, right? When there are two or three. So it's best to follow what? This method, in which we enumerate by combinations or even by permutations for this matter, for that matter. Had these all been different, like H1, H2, T1, T2, then I would have just put 7 factorial. But since two heads are the same and five tails are the same, so I need to divide by 2 factorial, 5 factorial.
Okay.
So that's nothing but 7C2, because 7C2 is 7 factorial divided by 2 and 5 factorial.
Okay. Okay. Okay.
That's NCR, right?
Mhm.
So that's how it is. So what is the answer here?
7C2, that is 42 by 2,
Divided by 2
21
raised to
by 2
7.
raised to 7. Huh.
Yeah, that's the answer, ultimately. Yeah.
Hmm.
So enumeration not possible everywhere. Wherever it's not possible, use combinations or permutations formula.
Hmm.
As simple as that. So algorithm is simple. Understand the experiment, create the sample space for the experiment,
Hmm.
find total, find favorable. If favorable can be found out using enumeration like this, great. If not, fall back upon combinations or permutations formula
Hmm.
to enumerate. Then find favorable, then divide that by total.
Okay.
Okay. Now, do you remember binomial theorem?
No.
Binomial distribution?
I mean, what is it?
Binomial distribution is to model number of successes. This is another way of solving these problems. Model number of successes. The question which I put here was 7 coin tosses. Yeah.
Mm.
7 coin tosses. That's the question. And a probability of exactly two heads. Now, my question is, what is a success here? Success here is getting a head.
Hmm.
Okay. How many successes they're talking about? Two, right? Two heads. Now, what the binomial distribution or modeling this success, the formula looks like this: NCR into P raised to R Q raised to N minus R. I'll explain this. N is total number of coin tosses. R is total number of successes. P is probability of success. Q is probability of failure, which is 1 minus P. So in this problem, can I say we are talking about two heads exactly, right? Head is a success. Number of successes is 2. 7 coin tosses. So this is N, this is R. So 7C2 NCR. I'm applying this formula. NCR into P. What is the probability of a head? Half, no?
Mm-hmm.
Half raised to how many successes? 2. And failure is probability is also half. How many failures? 7 minus 2, 5. So same is the answer. 7C2 into 1 by 2 raised to 7. Answer is the same, what we got in the last. But another way of looking at it, binomial distribution.
Hmm. I've
This
never
is
thought of
only
this.
possible
Hmm.
when you are viewing it as a success. So you need to identify what is a success and then find the probability for say two successes. For instance, now if I tell you, give me the probability of two heads or three heads in seven coin tosses. Now, how will you do that?
Two heads or three heads.
Ah,
So success would be half, failure is half. Two heads or three heads in what? This seven only.
so probability of two
Seven C
heads
two.
or three heads.
So seven C3 into half raised to.
That is the for the first one. That is
Uh,
for two heads
I'll add it to seven
and
C3.
add three heads. So 7C3 into half raised to cube and half raised to 4,
Uh,
which is the same thing. 1 by
uh,
2 raised to 7, right? So two of these appear. So
uh,
hence enumeration is very difficult sometimes. So hence this binomial theorem or raw counting in the form of this NCR works or NPR. Make sense?
okay. Okay. So once again, you said this is applicable only when there are successes.
Only when you're able to solve it as a success. If you identify an event as a success and they're asking you number of successes, then you can do it. Modeling number of successes. So first of all, success is getting an H, and how many H? 2H.
Hmm.
Here there were 2H or 3H. H is the success, and the
Hmm.
number is 2 or 3. So apply binomial like this.
Okay.
Make
Okay.
sense?
One second, I'll just write this down. When
Yeah.
asked for a success. So n is number of combinations, right? N is not number of combinations, is it?
N is number of tosses. Count total.
So this is only for coin toss, or what?
It can be for any experiment which involves number of modeling number of successes out of N. R is the number of successes out of N. N is the number of times the experiment is repeated. Your coin toss is repeated 7 times. That becomes your N.
Okay. P is probability of success, Q is probability of failure, R is what you written? Success.
Number of success.
Number of
Number of
success.
successes. Yeah.
Okay. Let's see how to apply this. Hmm.
We have two or three more problems where you can apply whatever
Okay.
you like. The first method or this method.
Yeah.
So you have a choice now. Should we solve?
Yeah, let's move on.
Okay. Now tell me what is this?
Uh, each of three fair dice has six sides. They say, I don't know. Hmm.
Now what is a success here?
Success is showing two dice show a one.
Your
So
question
two on
stem, this is
three.
the question stem. So this will be a success. That will tell you what is a success. Okay.
Uh,
So can I say probability of success is 1 by 6, getting a 1, and failure is 5 by 6, other numbers.
no, but two will get one, na? There are three dice. If two need to get one, it should be two by
No, 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 no.
three into.
No, 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 no. One showing a 1 is a success, and probability of getting a 1 is 1 by 6. This
Acha.
is R. This is R, number of successes.
Okay. Okay.
And
Okay.
three fair dice. This is n. How many times the experiment is repeated? Three times the dice is rolled. So that's n. How many
NCR. It's roll
times?
3 times. NCR is 2. P raised to R. P is what? 1 by 6. R was what? 2. And Q is 5 by 6. N was what? 3. 2 minus 2. Okay. 3. So 5 by 36 to 72. D. Okay. Now, if I try the other way that you had said, no, 3 fair dice at this, 3 are rolled at the same time. If they show a 1. Okay, so 3 by. How will you do it? So, one second. If I try the other way, these 3 dice are rolled at the same time. Probability that 2 of these are show as a 1. So, the same thing, right? 3 into 2 by 3. That would be the numerator. है ना?
Yeah.
And but the answer is 5 by 72. No? Okay. And each of the 3 fair dice has this. So, if I find the number of these things that can come up, 6 into 5 into 4. It's clearly wrong, no?
What are you doing?
No, I'm saying in the other method. See, the first
Hmm.
method we got 5 by 72. The other method, how will you solve this? So each 3 fair dice has 1 to 6, and 3 are
Yeah.
thrown at the same time. Right? So
Okay.
I'll have.
One second. One second. So here we have 3C2
Uh,
NCR, 1 by 6 raised to 2, and
uh,
5 by 6 raised to 1, correct?
uh.
And that is your 5 by 72, correct?
Correct, correct.
This is method 1. Method 2, rather, binomial distribution method. Now, method 1, you're saying how to do it. Now,
Mm-hmm.
right, that is enumeration method. Write the 3 dice. Okay? Two of these will show a 1, which means what? 1, 1, x, 1, 1, x, 1, 1, x. How
Uh,
many ways are there? 3
3
ways.
ways. Correct.
3
Now the
ways.
X can
And
be anything, no?
now 3 ways, but what is the probability of every scenario? Can I say
6.
1 by 6 square and 5 by 6?
What? Why? Oh, hey, 1 second. 1 1 x, right? It could be 1 1 1, 1 1 2, 1 1 3, 1 1 4,
It cannot
etc.
be 1, 1,
6.
1. It will be 1, 1, x, where x is not 1.
So
So
then
hence,
5.
1 by 6, 1 by 6, and 5 by 6 for each scenario. Scenario 1, 2, 3. And there are 3 such scenarios. So 3 into this will give you the answer, which is the same as this, same.
What did you do? 1 by 6 square by into 5 by 6.
1 by 6 square is because what is the probability of getting a 1? 1 by 6. Another 1 by 6. And getting an x, which is 2,
Okay.
3, 4, 5, 6. So that is 5 by 6.
Okay. What if we do it this way that if I'm throwing 3 dice, uh, right? So the number of outcomes would be 6 into 6 into 6. So that's my denominator, right?
Okay.
Numerator, like you said, these are three ways I can get this. So then the first way is 1, 1, x. X could be anything between 2 to 6.
Method 3 is counting method. What you are getting at. I'm understanding where you're getting at.
Uh,
So here you're saying, okay, you have one, and then can I say 5 ways in which you can put?
I got the same answer 5 by 72. So
Then
5 plus
five
5 is
ways,
5.
and 5 ways in the third. So there are 15 ways
Ah,
divided by 6 cube.
correct.
Okay. So that's the same thing only. No?
Huh.
Yeah. So there are always three methods.
Mm-hmm.
Counting, pure counting method, then scenario. Okay. Here we took probability. What is the difference between all these? This is pure counting. You are counting each scenario, right?
Mm-hmm.
And then adding these up. In this method, method one, you are doing probability of every scenario
Uh,
and multiplying by number of scenarios,
mm,
which is why you multiply it by 3 because there are 3 scenarios. And in M2, it just uses binomial distribution, which means modeling one as a success, getting a one as a success, and then finding how many ones, which is
yeah.
R is 2. Yeah. Is it better?
Mm-hmm. Yeah, yeah, yeah.
Yeah. So attacking the same problem 3 ways.
Okay.
And this will is going to build your concept now. Now you will know either you do scenario, number of scenarios into probability, or you just count within the scenarios and add, or you model it as a success, whichever is whatever is applicable and faster and more
Mm,
efficient. Got it?
yeah.
Yeah, this is good. Okay, next.
We rolls two where each has 6 sides.
Now this you will do for homework.
Oh
Slide
no.
18.
Okay.
Okay, tell me what about this?
Okay, no? Oh, the bubble. I mean, 2 by 2 raised to 6, I guess.
2 by
2 raised to 6.
okay. Yeah. So it can only be this.
HTHG or THGH?
Yeah. So 2 favorable. Total is 2 to the power 6. So answer is 2 divided by 2 to the power 6.
Mm-hmm.
Nice. Getting better. Okay. This
Rolling
you
and
will do by yourself, 23. So just make a note, 1823.
okay.
Okay. Now tell me quickly what is this?
How many 10-digit numbers can be formed? Oh no. Okay. 2 and 5. 2 and 5. I don't know. Okay. And,
So how many digits are there? 10.
mm,
And each digit can be filled in how many ways?
10.
2 or 5. 2 ways.
Oh.
Two
Oh.
ways. So what is the answer?
2 raised to 10.
Yeah, that's the answer.
Oh.
Yeah. No other complication there. There's no other constraint. You just have to say, okay, there are 10 such digits and 10 digit number, I mean, and each place value can be filled in two ways or two digits. So there are two choices. So how many total choices are there? 2 to the power 10. Yeah. Cool.
Over. Over. Over.
Next.
Twenty-six square into 10 raised to 4, no?
Yeah, 26 square into 10 raised to 4. That's right. Correct. Now you're getting it. Okay. All right. This one.
X. Same thing, no? 2 raised to 4.
2 raised to?
2 raised to 4. No, the first four
Yeah.
outcomes that are fine and everything has 2.
Exactly.
Oh.
Last flip must be heads.
Hmm.
Okay.
Cool. No, it's correct, no?
Yeah, 2 raised to 4. Yeah, yeah. Okay. Next.
How many parts are going to be formed? It's going to be repeated. 1, 2, 3, 4, 5, 6. So 5 into 5 into 4 into 3 into 2. कितना होता है? 20.
600.
हाँ, ठीक है. 6,600, correct.
Correct.
हाँ,
Good. So first place in only 5 ways.
because 0 is there.
You can't put 0 there.
No.
Second place, remaining are 5. Third place, 4, 3. It's all distinct, right? Cannot be repeated. Yeah. So it's 600. Yeah. Good. Next.
Students are arranged in a line. Beth is not allowed to stand. Yeah, Beth is not allowed to stand next to Dan. So 1, 2, 3, 4, 5. So actually, there are 4 combinations. 1 minus 4 combinations, actually. How do you do 4 combinations? 5, 4, 3, 2. 23s are 62s are. Okay. 20. And oh. Is it 96?
96. No.
See, total ways are 120. Okay, 5, 4, 3, 2, 1.
5
Mhm.
factorial.
Now, if Beth and Dan sit together,
Hmm.
right, it would mean it's 432.
So complement method you're doing. Total minus together.
Huh, huh,
So BD is one group, and then there are three more.
huh.
So that's 4 factorial ways.
How much divide by 2?
No, not divide by 2. Into 2 factorial. BD
Oh,
can be DB also.
oh.
Hmm.
It, 12 twos are 24, 48.
You will divide if they are similar, but here they are different. So you will multiply.
Mm,
Within them also they permutate in two ways.
mm-hmm. 72 ways. Okay.
Yes. Better?
Yep.
Okay, now this should be easy. Come on.
That can be arranged 1, 2, 3, 4, 5, 6 factorial upon 2 factorial and a 2 factorial.
Easy.
Mm.
Now you're going to solve probability in 10 seconds.
If questions like this come, I'll be very happy.
Okay, now let's see. This this is tricky, huh?
Six digits where how many different 6 digits are there? 3. Mm. 1, 2, 3, 4, 5. One of the digits is a 5. 1, 3, 2, 4, 1, 5. And each of the others is 7, 7, and 8, 8.
So two digits left.
2, 3, 4, 5, 6 factorial upon 2 factorial and a 2 factorial, and this into 2. We'll have to solve it. 6, 5, 4, 3, 2 upon 2. 30 to 12, 3, 7, 30, 360. Why are there such big options? This sounds wrong. I got the smallest option. It's 60. What's there? Correct. No. What is this? 360 is not the answer. What?
360 is not the answer.
The other is 7 or 8. No, so I have to add it, not multiply. 2 to 60. 30 into 6. 6, 3 is a 180. I'm still getting the same thing. I mean, see, uh, 6 factorial, okay, upon the repetitions, that is 2 factorials for the 4s, 2 factorials for the 7. And since it can either be 7 or 8, I will have to multiply it by 2.
So what do we
Huh?
So we get 360, is it?
Oh. 6,
Are you
5,
sure?
4, 3, 2 upon 2 into 2 into 2. 4 threes are 12 and 6 is a 30. 12 threes are 36 into. Huh.
Okay, so it can be 7 7, it can be 8 8, or it can
Uh,
be 7 8.
oh, it can be 7, 8 also.
7 or 8, yeah. So counting method, this will be 6 factorial divided by 2, 2 factorial. This also will be the same.
Mm.
And this will be 6 factorial divided by 2 factorial.
2 into 2. 720 plus 360. 1080.
6 into 5 into 3 into 2 is 30 into
It can be 8
6.
and 7 also, no?
30 into 6. This is 180, right? This is also 180. 360. This will be 360. So answer is 720.
Achha, so 8 and 7 I don't have to take.
Which one?
Oh, no, nothing. Nothing.
8 and 7
This
we no need, no, because
7.
it's permutations. It's coming here. 6
Yeah,
factorial.
yeah, yeah, yeah.
Yeah, yeah.
Hmm.
It's a repetition of scenario.
Okay.
Hmm. If you take 7, 8, then you need to divide by 2. If you're
Hmm.
taking 8, 7 also,
Hmm.
that means you're fixing.
Hmm. Okay.
Hmm. That means it's not a permutation between 7, 8.
Hmm.
Got it?
Yeah.
So in place in questions where we are fixing the position, their permutations will not be allowed.
Hmm.
So there we will have to divide by 2 or 3 factorial or whatever that is.
Hmm.
Yeah, basically becomes like a combination problem then.
Hmm.
Yeah, but we won't get into that complication here. It's simple. Just keep it 7, 8. Just permutate it and divide by 2 factorial because there are 2 fours. Yeah.
Hmm.
So that's that. Pretty cool. I hope it's better. We have not completed this. We will have to
Fine.
continue tomorrow a little bit and then
Okay.
we will go into something else.
Okay.
Yeah. I will ask you to solve some questions from here,
Oh,
which you can try. So I'll send you the deck with the
yeah.
question numbers. Yeah.
Okay. Let me know.
Take care.
Okay.
Cool.
Thank you.
Take care.
You
Bye
too.
bye.